Okay, I asked you to do, today in class, we started number 5. Some of you probably finished it, some of you need me to go over it. And then I asked you also to do number 6. So number 5, a 60 kilogram box. So again, first thing you do is draw it. FG is going to be acting down. FN is going to be acting up. Put our 60 kilograms in here. Is being accelerated across a level surface at a rate of 2 meters per second squared. So AX is 2 meters per second squared by a force of 220 newtons acting parallel to the surface. So our F here is 220 newtons, and acting backward will be friction. Okay, what is the coefficient of friction? So we're looking for mu. So earlier today we said there's always 3 steps. Some of the forces in the y, some of the forces in the x, and FFR equals mu Fn. The order depends on what we're giving. But 99 times out of 100, you start with some of the forces in the y. And you do this to get Fn. So this box is not moving in the y, so MAY is 0. So it'll be Fn minus Fg, because it's going down, equals 0. So Fn equals Fg, which equals mg. So Fn equals 60 kilograms times 9.81 meters per second squared. So Fn is going to equal 588.6 newtons. Okay, first step. We want to end up finding mu, so we're not going to do friction is equal to mu Fn yet, because I'm trying to solve for mu, which means I need friction and I don't have it yet. So instead, we're going to go to some of the forces in the x next. And in the x direction, there's the force you're pushing with going one way and friction going backward. So F minus friction is equal to MAX. It's supposed to be an x there. And we're looking for friction. So bring friction to this side, bring MAX over. So it'll be F minus MAX equals friction. Okay, so the force of friction is equal to, F was 220 newtons, minus M was 60 kilograms. And it told us in the question the acceleration was 2 meters per second squared. So 60 times 2 is 120. 120 from 220 leaves us a friction of 100 newtons. So we now have our force of friction, we have our Fn, now we can find mu. Because rearranging this, mu is simply friction divided by the normal force. So it's equal to 100 newtons divided by 588.6 newtons. And so you should get a mu of 0.16989, I believe it is. Okay? All right. Example 2 is a little tougher. Example 2 says a cart is being pushed across the floor. So again, we're going to do our level floor. Cart is being pushed across the floor with a force of 300 newtons acting parallel to the floor. Fg, of course, is acting down. Fn is acting up. Friction will be acting backward. The coefficient of friction, so I'm telling you mu, is 0.32492. And the cart accelerates at a rate, so I'm also telling you AX, at a rate of 1.5 meters per second squared. This time it wants to know what is the mass. Okay, so remember I said there were 3 steps. First step is usually sum of the forces in the y. And when you don't know where to start here. This cart is not moving in the y direction. So it's going to be Fn minus Fg equals 0. So Fn equals Fg equals mg, which should be looking familiar by now. But this time the problem is we cannot find a number for this. We don't know m. Okay, so we can't get our Fn. So your choices now are to give up and go to bed, or to say, well, it must be going to work out if I go to some of the forces in the x direction maybe. So some of the forces in the x direction is equal to max, and there are two of them. F minus friction is equal to max. Now the problem is I don't have F and I don't have M. I don't have friction and I don't have M. But I can get an expression for friction because I know friction is equal to mu Fn. And I know Fn is mg. So friction is really equal to mu mg. I have the mu, I know the g, I just don't know the m. But it's what I'm looking for. So I can sub it in up here. So F minus mu mg is equal to max. Now I have one equation with two unknowns, which means I'm going to be able to solve for my m. So take your m's to the same side, so add the mu mg. So it'll be F is equal to max plus mu mg. And now I have two terms with m in it, so I do what we've been doing from the beginning of the year. I pull it out, I factor it out. So it'll be ax plus mu g, that'll be left in brackets. I want to solve for my m, so I divide both sides by the bracket, ax plus mu g. Ax plus mu g. It'll cancel on this side, and so I'll be left with m is equal to F over ax plus mu g. And now I fill in my numbers. F is 300 newtons. A was 1.5 meters per second squared, plus mu was 0.32492 times g, 9.81 meters per second squared. Now when you go to type this in your calculator, make sure you have brackets around this whole bottom part. Okay, so 300, open the brackets, type the stuff in, close the brackets, press equals. And when you do, you should get a mass of 64 kilograms. Cool? I think it's cool. Okay, so it's like systems of two equations again, right? We had two unknowns here, so we needed to go to another equation to plug in so we get one unknown in our equation that then we can solve for. So I think you need a little more practice with this one, so I'm going to give you another example. Okay, so the other example is a box that's sitting on a level surface. Okay, and I want you to try this. Sitting on a level surface, unknown mass, but you're pushing it with a force of 1,172 newtons. Fg, of course, is acting down. The normal force is acting up. Friction is acting backward. The coefficient of friction is 0.2, and the acceleration is 0.968 meters per second squared. Find mu. So stop the video, find mu, restart the video. Okay? I'm waiting for you. All right, so hopefully you did this. So again, you start with sum of the forces in the y. When you don't have a clue where to start, always start with sum of forces in the y. It'll be Fn minus Fg equals 0. So Fn will equal Fg, which means Fn will equal mg, but again, we cannot find it because we don't know m. But we do know that friction is equal to mu Fn. And so that means friction is equal to mu mg. Again, we can't find it because we don't have the mu. But we now have an expression for friction. And so we can go to the x direction. And in the x direction, there's F minus friction is equal to max. So F and friction is mu mg equal to max. So take the mu mg over to the same side. So max plus mu mg, factor out the m. So m brackets ax plus mu g, and now divide both sides by the bracket. And you'll get m is equal to F over ax plus mu g. So m is equal to 1172 newtons over, what was it? I forget. 0.968 meters per second squared plus 0.2 times 9.81. Got to run out of time, but you should get a mass of 400.